or slope of a line segment is given by rise over run. So, whew, what do you think rise has to do with on a graph? Y, yes. And what do you think run has to do with? X. Does this ring a bell similar to something we just did? Rate of change, yes. So in applied, in applications, we talk about rate of change. In pre-cal, we talk about the slope, because we're looking at slope of lines all the time. So slope is rise divided by run. So the rise is the change in the vertical. Some people have to know which one's vertical and which one's horizontal. We got that mixed up on the test. I don't know if that was somebody recognize who I'm talking about. Okay. If I move up, would that be considered positive or negative? Why would it be considered positive if I'm moving up? Yeah, because you're gaining or you're increasing. That makes sense as positive, right? Moving down is negative. So this line from A to B, would this be considered positive slope or negative slope? Positive. Anything going up to the right is positive. Anything going down to the right is negative. And you might argue, oh, well, it's going to the left. No, it's just like you read. When you read a book, you read from left to right. So whatever's happening on the right-hand side, is it going up to the right or down to the right? Yeah?
I read a book one time.
Nice. Okay, the run is the change in the horizontal distance. Moving right, would that be positive or negative? Positive. And moving to the left, negative. Think about getting somewhere. You know what I mean? If you're reading from left to right, if you're going to the right, you're getting closer to it. If you're going to the left, you're getting farther away. Does that make sense why these are the signs they are? Okay. Here's the other kicker here that I've been saying all along. A line segment that goes up to the right has a positive slope. A line segment that goes up to the left, again, I wouldn't say it as up to the left. Yeah, and that's where they're saying it's down to the right. I would say it as down to the right has a negative slope. I would never learn this as I'm going to the left. I'm starting here going down to the right. Okay. So what happens if we don't go up or down, but we just go to the right? Well, that means we have a slope of 0. So a horizontal line has a slope of 0 because we're not going up or down. So my rise is, what's my rise if I'm not going up or down? 0. And my run in this case, I'm going 1, 2, 3, 4 to the right. So what's 0 divided by 4? 0. When a line segment is on a grid, we count the squares to find the rise or the run. Okay, so I want you to find the rise and the slope of AB, the slope of CD, and the slope of EF. So I'll give you a second to measure that. Okay, so does anybody know the variable or the symbol used for slope? It's not X. It's not Y. I'm sorry? It's M, yeah. But you notice on your calculator, they actually used A when they did the calculation, remember, on the test? So it's kind of if you look at most textbooks and most countries, they will use m for slope. And apparently the origin of m for slope comes from the French word manger. No. What? No, it's not math. French word, people. And think about slope when you think about the French word. Monter, which means to climb. To climb, yeah. So this is really m of AB, m of, so m is slope, and that is the French for mont. Maybe that'll be a bonus thing somewhere. What did that mean in the translation again? To climb. Well, you could say slope, but it's not AB because you're not measuring from A to B. You're measuring the slope. Okay, so I'm going up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5. So that is 6 over 5. Is that what you got for AB slope? Okay, C to D. Well, technically I have to go from D to C, right? So I'm going down 2, 4, 6, 8 over 1, 2, 3. So this would be negative 8 over 3. And EF, I'm not going up or down, so if you want, you could say 0 over 3, but it's 0. Anytime you see a horizontal line, you need to make a decision and write it as 0. Okay? You can't leave it as 0 over 3. That would not be an acceptable answer. Okay, so it doesn't matter where I put the negative as long as the fraction is negative or the number is negative, because it's going down to the right. Yeah, I can write it like this. Or I could write it as, does everybody see that's the same slope? The negative doesn't matter where you put it. However, when I calculated this, I went down. So do you see why I put the negative with the 8? It doesn't matter where you put the negative. As long as you know if you're going down to the right, it's negative. Okay, I'll give you a second to figure out this now. Slope needs to be in lowest terms. So if it's a fraction, like for instance 4/8, you should reduce it to 1/2. If it's a fraction like 8 over 4, you should reduce it to the whole number 2. Okay? So I'll give you a second to do this. Okay, so rise over run, 3 over 4, yes? Rise over run, so 1 over negative 2, you could have negative 1/2, right? Rise over run, this one I have to reduce to negative 2. 2 over 10, this one I have to reduce to 1 over 5. Okay. No. I just finished saying we don't like decimals in pre-cal, right? Yeah. Okay, I want you to draw a line segment with the following slope 3. Now 3 doesn't have a run. How could I make it a run with the whole number 3? Okay, I see 6 over 2. Anybody else? 3 over 1. 3 over 1. What did you say?
900 over 300.
Yes, you're going to do 900 over 300. Although you're correct, I doubt you're going to use that. So that means we're going to, I don't know, where do you want to start your point at? So first off, a point
3, 1.
is a coordinate. So 3, 1 we're going to start at? Okay. We're going to start at 3, 1. Okay. Yeah, let's just start at 0 at the origin. It doesn't have to be at the origin, by the way. But if we start at the origin, we're going to go from there. We're going to go up 3, 1, 2, 3 over 1. Or you could go up 6, 1, 2, 3, 4, 5, 6 over 2. Does everybody see if I connect those dots, they would be on the same line segment? I hope everybody has a ruler. Oh, my ruler did not connect the dots very good. There we go. Okay. I want you to draw a slope of negative 4 over 5. Should I start at 0, 0 for this one? No. Where do you want to start at for negative 4 over 5? Where do you want to start? Let's all start in the same spot. Okay, 4 is not a coordinate, so let's try again. 0, 4 I hear. Oh, okay, sure. Let's start right there. Everybody start at 0, 4 and go a slope of negative 4 over 5. Okay, does everybody understand this can be negative 4 over 5, or you could have it as 4 over negative 5. It doesn't matter, right? Most people will use this method here, having it going down. Because again, we read from left to right, so having this negative 5 means I'd be going left, and it doesn't really work as great. But sometimes you're forced to do that. Okay, so I'm going to go down 4 over 5. Here I go, connect the dot, done, right? Okay, so by the way, if it asks to do a line, what would be wrong with my answer? Is this a line or a line segment? Line segment. What makes it a segment and not just a line? Huh? It ends at the points. They're endpoints, right? A line segment has endpoints. What does a line have? Arrows. But you're going to lose marks if you draw a line just from 2 dots and end it like this. This asks for a line segment, so that's why this is correct. But we're going to be graphing lines from now on, which means you're going to be extending past the points with arrows, okay? Okay, so different line segments on this line have these slopes. Okay, so does everyone understand a slope of 3 is 3 over 1, 6 over 2. It doesn't matter where you measured on the line. It's going to have 3 all day long on the slope, right? So if I go from here, I'm measuring 6 up, 2 over. Or I'm going 3 up, 1 over. Do you see I could have measured 3 up right here? If I went from here to here, that's 3 up, 1 over. Do you see no matter where you measure it, I could go up 900 over 300 and get a slope of 3 as well. Would it be very practical on this graph? No. But does everybody see it doesn't matter where you measure it. If you go from point to point, or you go, if you miss this point and go up 6 over 2, you'll still get a 3 slope. Make sense? Okay. So a slope of 3 can be written in any of these fractions. So 3 over 1, 6 over 2, and we're going to use 900 over 300. We wouldn't use that, but you know what I'm saying. Probably 9 over 3 you would use. Yes? So this line has a slope of 3. We can find the slope of a line by choosing how many points on the line. Any 2 points on the line. It doesn't matter what the points are. The choice of the points does not affect the value of the slope. It's just you're going to be dividing by different numbers. You'll still get the same. So the slope of the line is equal to the slope of the line is equal to the slope of what? That's the only thing I can think of it. So yeah, each segment of the line. That's a weird word that I pulled out, but anyways. Okay, so do you see now in the computer program, if it goes to the end of these coordinate plane, that actually is their way of drawing an arrowhead, okay? So it bothers me that their program, they can't put arrowheads on here. So just get in the habit of, if it's a worksheet, to put the arrowheads on it. When you're drawing lines, you have to have arrowheads or you're going to be losing marks, right? That will be an error code. So anyways, so it doesn't matter which points on the line segment you choose, any 2 points. So you can measure this from here to here, or you can measure it, I'm going to use a different color, from this red dot to this red dot, or you can measure it from this green dot to this green dot over here. It doesn't matter. The slope of the line is the slope of the line. It doesn't matter where on the line you're measuring it. Okay, so I'm going to give you a second to find the slope of these lines. By the way, they're going down to the right, so both answers should be negative. Okay, let's go over this. Okay, so I'm going to measure this. It would be down 1, 2, 3, 4 over 1, 2, 3. So did you get negative 4 over 3? Yes? Yeah, 1 second. For this one, I'm going to go down 1, 2 over 1, 2, 3, 4, 5. So that is negative 2 over 5. If anybody got negative 8 over 6, you have to reduce it, right? Okay, in example 4, we counted the squares to find the rise and the run. When the line is not drawn, we can use a formula. A formula to find the rise and the run. So does everybody see when I'm counting this? When I'm counting the squares, do you see if this coordinate, for instance, it's in between, I don't know why it's in between, whatever. But do you see if I'm actually counting these squares, say I'm counting 3 there, if I actually take the height here and the height here and subtract it, do you see I get the rise? Same if I take the distance from B and A and subtract it, I'll get the run. So this formula, y2 minus y1 over x2 minus x1, also calculates the slope. When would I want to use it? If I don't have the graph in front of me, I just have these coordinates here. I just plug it in. So, well, how do we use this formula? Well, if this is the first point, that gets designated the sub-ones. So is negative 3 an x or a y? It's an x. So this would be x1. Negative 2, is that a y or an x? Y. So this would be y1. This would be, because it's the second point, what? X2. And this would be y2. So we're going to put it into the formula. M equals y2 minus y1 divided by x2 minus x1. So 5 subtract negative 2 over 10 subtract negative 3. So what do we get on top there? 7. What do we get on the bottom there? 13. Okay, so I'm going to give you a second to try the next one here. Okay? Okay, so again, this would be 8 subtract negative 7 over 3 subtract negative 4. So you get 15 over 7. Is that what you got? Okay, so now we're going to draw a line GH through G with a slope of 5 over 2. So how would I draw that? Well, first I have to know how to graph negative 2, negative 1. So negative 2, negative 1 means I go 2 to the left, 1 down. So there's my point. And what does a slope of 5 over 2 mean? Up 5 over 2. 1, 2, 3, 4, 5 over 2. Is that where you got it? And you're going to take your ruler. Is this a line or a line segment they're asking for? It's a line. So don't just draw that. That would be incorrect. Okay, so you need to extend this. Do you see past the points? And then what's the final thing you have to do? Yeah, you have to do arrowheads on this. Okay, do you guys have